Hi everyone, sorry I can't be there with you, especially on a day where you're preparing for an in-class assignment piece. But I trust that you will come out victorious, that you're studying really hard, and you will give your brain the opportunity to work and think and grow instead of relying on AI. Now, I know that I can't be there with you, and so I can't answer your questions. The least I can do is answer the 3 test prep or assignment prep questions I gave you the other day, providing full solutions, and also giving you my thought process as I approach questions I've never seen before, in hopes that that might help guide your thinking along the way. Okay? If you're still having trouble with something, please email me. I'll do my best to get to it during the weekend. But one mention about AI, please, even if you're stuck and if it's taking you like an hour to go through, please don't resort to AI. That's an extra hour of your brain thinking that you are robbing yourself of. That opportunity to grow, you're not letting yourself have. I know that sounds a little bit weird, but you are self-sabotaging your future self. And so really, even if you can't help it, pretend AI doesn't exist and work through it and work until some kind of breakthrough happens. And that is when neurons have grown. Okay? So without further ado, let's get to it. You have a fraction. You have just a regular term. Now, if I were to look at this, number one, I see that this is a double angle, whereas this is not. So one thing I could do is maybe turn this into single angles, right? It's not a compound angle, rather it is just, it's just sine theta plus theta, or if I remember that sine theta plus theta, it's going to be sine cos plus cosine, right? So I could turn it that way so that I have single angles. Another thing I can do is see that they're all in tangent, whereas this is sine and cos. So why not change everything into sine and cosine in hopes that maybe something will simplify and open up in itself. So to me, I feel like the left side is a little bit more complicated than the right side. So I'm going to, in the back burner, I'm going to remember that sine 2 theta is the same as sine theta plus theta. And using my double angle formula, I'm going to rewrite this as sine theta cos theta plus cos theta sine theta, which happens to be the same term, and that is why we have sine theta and cos theta. Remember, since we have this as an identity, you can go straight to that right away. No problem. So that's the right side. Now, before I continue, some of you might have had the training in grade 11 where you are only allowed to change one side and make it equal the other side. That's not necessarily true. As long as you can simplify one side and simplify the other side, you're good. And I feel like I would have talked about this in the first day of trig identities. So let's go. 2 tangent is 2 times sine x over cosine x. And that is all over 1 plus sine squared over cosine squared. Looks pretty messy, but there's more I can do. I see there is no fraction here, so I'm going to try to simplify this and see what happens. This is still 2 sine x over cos x, whereas the denominator, 1 could become cos squared over cos squared. So this is cos squared over cos squared plus sine squared over cos squared. So the denominator is the same and results in this. And at this point, you should be really happy because anytime that happens, you know you can simplify and make things a lot less complicated. That's 1 over cos squared x. From there, I am going to take this fraction divided by another fraction and simplify it by multiplying the reciprocal. So this is 2 sine over cos divided by 1 over cosine squared, which is the same as multiplied by cosine squared x over 1. Cos times cos, divided by a cos. I can cancel this with the exponent. I have 2 sine x cos x, which is equal to right side QED. Okay, and that's it. So what are some things that we can take home from this? Number 1, changing all tan ratios into sine and cosine might help you because there's a lot more identities that involve sine and cos in our, I guess, our toolbox than we have for tangent. Number 2, you may want to start with the part that's more complex looking because there's more stuff to work with. Things that are more simplified, you have to actually unpack it and make it into a more of a mess if you want to make it look like the other side. So it's not the best place to start. And number 3, at any point in time you have a square, you actually might sort of, be sort of really excited inside because there's more room for the Pythagorean identity to be used. Okay, let's see number 2 and see those parts also coming to life. Here we go. We have, once again, I have some kind of square. I have a double angle. Here I have conjugates. Some things that I see that are similar. This cos plus sine is right here, but this is not a square, whereas the left side is. So maybe there's a way that this creates a cos plus sine, and it cancels the exponent out, allowing you to have this left over. I don't know. That's just a thought. Now, between these two, they're both pretty complex, but I feel like because of the square, because of the 2x, there's more mess to work with on the left side. So I'm going to start with that. So right side I'm going to leave. Left side is equal to cos 2x. I'm going to leave that here. Cos x plus sine x. And then cos x plus sine. Okay, I see where we're going. I think I was right in trying to make one of the brackets disappear. In other words, cancel it out, or divide it out rather. And the only way that happens, if I remember correctly, is having cos 2x be rewritten using this identity. And I do this because this is actually a difference of squares. A lot can be done with a difference of squares. When you have a difference of squares, a squared minus b squared, you know from factoring and quadratic functions and whatever, that it could equal a plus b and a minus b. And I think you see where I'm going now. I have a plus, I have a minus. On the bottom, I have a plus and another plus. One of those factors will divide itself out, leaving me with the right side, QED. That was pretty simple. Not going to waste your time. I'm going to continue moving, assuming that you've tried this at home. Number 3. Again, what part looks complex? I would say the left side. Here I have 2 fractions, where here I have 1. So you know at some point I have to bring these denominators to be common and add this all up to become one gigantic fraction. Second, I see the right side terms being sine and cos, whereas the left side terms is all cosecant. So maybe I can clean this up by turning all of these into 1 over sine, and some kind of magic happens. So let's try it. The left side is equal to 1 over sine x all over 1 plus 1 over sine x plus 1 over sine x all over 1 minus 1 over sine x. At second glance, it actually might be easier to make the denominator common, which will create a cosecant squared, and then I could turn that into a 1 over sine squared. But since I've started, whatever, let's try it. The denominator here is, let's see, sine over sine plus 1 over sine. The denominator becomes sine x plus 1 all over sine x. And this is 1 over sine x plus the denominator sine over sine minus 1 over sine. This would be sine x minus 1 over sine x. And the numerator still 1 over sine x. Continuing on. Not the same. How about I simplify the fractions as is? I am going to fraction divided by a fraction is the same as 1 over sine multiplied by this reciprocal. This becomes 1 over sine x plus 1. And this 1 over sine x multiplied by sine over sine minus 1. This becomes 1 over sine x minus 1. Okay, we're getting somewhere. Very similar to my situation above with cosecants, but now I only have sine. So let's keep going. The only way I can make the denominators the same in this case is if I multiply them both. So this is going to be sine x plus 1, sine x minus 1. The numerator becomes sine x minus 1 plus sine x plus 1. I didn't bother with brackets because it's an addition. Distributive property won't change the signs anyways. So we have sine, sine, negative 1, positive 1, leaving me with 2 sine x. Sine plus 1, sine minus 1, that is conjugates. So when I multiply it, I will get myself sine squared minus 1. Which I think is very similar to the right side. Negative 2 sine cos. Okay, I see where this is going. There's only one way I can change this into cosine. If you recall, sine squared plus cos squared of an angle is equal to 1. And so if I subtract 1 from both sides, and I subtract cos squared from both sides, I will have this, right? So sine squared x minus 1 is equal to 2 sine x over negative cos squared x. And that can be rewritten as negative 2 sine x cos squared x, which is the same as the right side. So what are some things that are new with this one? Well, it wasn't necessarily difficult. The only real identity I used was this. But what was required was a lot of fraction-based manipulation to make the denominators the same, changing cosecant or secant or anything of the like into sine and cosine. But otherwise, I think it'll be all right. I think if you thought about it enough and you worked your quadratics and worked all the different factoring skills and whatnot, you should be able to arrive at the same conclusion. One thing I am concerned about is making careless or incorrect simplification. Like, for example, let's pretend I see something like this. Some people will think that because you see a sign here and a sign here, they're allowed to simplify like that. You remember, you are not allowed to selectively simplify terms just because you see it. All of this together is a single term. And if you can't divide sine with a negative 1 together, sine squared and a negative 1 together, you can't divide them separately like that. Okay. I feel like trig identities is hard for a lot of people because it really brings your algebraic bad habits into the spotlight and it makes you uncomfortable. Let it come out. Fix it. It's not like it's too late. Consider it as a lifelong learning journey. Okay? So your work is cut out for you. You have plenty of identities to solve. If there are certain questions that you have a really, really tough time on and you want a full solution, like AI is not doing you justice because you're not using it, email me. I have been known to take the identities and give full solutions by video. There actually might be some YouTube videos I've made from the previous years too. In any case, think well, think hard, don't give up, and yeah, I will see you on Monday, all prepared for the assignment. Have a good weekend.